All right, everybody, new video, new type of function, and new rule for derivative, okay? All right, so on that topic, the function that we'll have in this video is a logarithmic function, okay? And before all of this, before I'm making this video with it in mind, that previous to me posting this video, I'll post some review videos about what logarithms are, okay? But I am taking that for granted in this video, what a logarithm is. Okay, but let's say with that, we have logarithmic functions. This is the natural logarithm, and this is the logarithm base number a, okay? And a is some positive constant. All right, so like log base 2, log base 3, log base 10, something like that. All right, so here are our rules for derivatives for those kind of functions. The derivative with respect to x of natural log of u is 1 over u times du over dx. So you could think about that as 1 over u times u prime, times the derivative of the u, okay? All right, that's how that one goes. And the derivative with respect to x of log base a of u is 1 over u natural log of a, then again times the derivative of the u. Okay, so those are our derivatives for different kinds of logarithmic functions that we're going to see. These rules would also work if that u right there was absolute value of u. And same with this one. This one would still be applicable if that was log base a absolute value of u. Why the absolute value? Well, logarithms are not defined or cannot be calculated for 0 or negative numbers. So sometimes that's corrected by putting absolute value around whatever this is so that it doesn't show up at least negative. All right, so that's why you sometimes see that. Okay, so now these are variations of the chain rule, but as the chain rule will be applied to logarithmic functions, okay? And they start to all look very similar after a while, okay? So I'm just going to go into work this problem right off the bat, because once you've seen a few of the chain rules, then they all have a very similar feel and a way of working to them. Now, in this one right here, then I noticed that u would be x plus 7 to the 1/2 power. That'd be the way that I would write it. Okay. So now this is one way to do this problem. It's not actually the easiest way to solve this problem and find the derivative, but for me to show you an easier way, I'd have to show you more rules. So I'm going to opt not to do that and just show you how you could do this one based only on this rule. So if I was going to find the derivative of this, it would be 1 over u, which would be like that. But then I'd have to find the derivative of x plus 7 to the 1/2 power. So, you know, that's what's going to be here. That's what du over dx means. So I'm going to do u prime du over dx, however you want to say it. And by another version of the chain rule learned about previously, this one would be 1/2 x plus 7 to the negative 1/2, then times 1. That rule comes from this. The derivative with respect to x of u to some power n is n times u to the power n minus 1 times du over dx. That's the chain rule as it will be applied to u, some function u to some power. So that's all I did right here is I brought the power of 1/2 down here to multiply. Then I have x plus 7 I have to take 1 away. So 1/2 minus 1 is negative 1/2. And then this part is the derivative of that, the u, the thing that's getting the power. So the derivative of x plus 7 is 1. Okay. So now that would be what goes next in here. But let me simplify that a little bit. Let's put this down here with the 2. We'll put it under the bar and make this exponent positive. All right. So a positive 1/2 under the bar. and then the exponent of 1/2 is a square root. Okay, so look at this. There it is, 1 over u, then times u prime, or du over dx. Okay, all right, now what would that give us then? Well, final answer, this might be our derivative. That's the correct formula with the rule applied correctly and so on. But as far as this goes, there's something that can be combined there. Okay, like I'll give you an example. Root 7. I don't know what root 7 is. Like I can give it a guess. I can probably get it pretty close. Okay, but I know that root 7 times itself is just 7. Like square roots cancel that way. Okay, so root x plus 7 times root x plus 7 is just going to be x plus 7. Okay, and there is our answer. Okay, do you see how the chain rule worked for that one? And then how I'd have to use this other version of the chain rule that we already learned once we get into this problem. Okay, all right. So let's try this one now. This one says y this time is a function of t. Okay, t to the 8th power times natural log of t. It says find the derivative of dy over dt. So you could also say this was y prime if you wanted to. But when we write this is called Leibniz notation. It means that y is the dependent variable and t is the independent variable. Y is a function of t this time. We wouldn't write dy over dx because x isn't the variable. Okay. Now, in order to find the derivative of this particular function this time, then I would have to use the product rule, because that function is the product of two functions. It's the product of t to the 8th power, that's one function, and then natural log of t, that's another one. So I'd have to use the product rule on that, and the product rule would call me out to find the derivative of this first function. What's the derivative of t to the 8th power? That would be 8 times t to the 7th power. Then times the second function the way that it is. So derivative of the first function times the second one the way that it is, plus the derivative of that second function. What's the derivative of natural log of t? Well, okay, that's like this, right? Natural log of something is 1 over that something times the derivative of the something. Natural log of u, derivative is 1 over u times derivative of the u. And that's true if that was u or absolute value of u, where u is just stands for whatever you have. So, all right, the derivative of natural log of t would be, let's do like this. Derivative with respect to t. T is the variable. Natural log absolute value of t is 1 over t times the derivative of t, right? 1 over u times the derivative of the u. Okay, what's the derivative of t? It's just 1. There's another rule that tells us that, all right? So that's just t. Okay, so we get, oh, sorry, whoops. We get 1 over t. So 1 over t right here is the derivative of natural log of t. All right, so I get 1 over t, then times t to the 8th power. All right, so then that's how the product rule works out, along with separately the rules for the derivative of t to the 8th power and natural log of t. Okay. All right, now let's see. That's my answer. I mean, if I use the rule correctly, then that's it. It would only be a matter of simplifying this. Okay, so let's see. Can I simplify it? Is there anything I can do here? Anything I can cancel? Well, I don't see. There's nothing I can cancel here. Oops. In that first term, you know, there's just nothing that can be combined. You know, this t that's inside the logarithm, it doesn't interact with anything on the outside, so I can't combine anything in here. And then what about t to the 8th over t? This is t to the 8th power divided by t. That'll be t to the 7th power. Okay, all right, got that. That reduces a little bit. Anything else? I could factor. I don't need to have t to the 7th in 2 places. I only need it in 1. I can factor it out. So I could do t to the 7th power times 8 natural log absolute value of t plus 1. That would be simpler. Factor out the common factor of t to the 7th. Now I have it in 1 place instead of 2. That is simpler by definition. 1 is simpler than 2. Okay, and then at that point, like, nothing else can be combined, and that's as far as we'll take it. All right, so there. But do you see how this rule applied to it? You know, do you see how based on that, I'm reading the derivative of natural log absolute value of t to be just 1 over t times 1, which is just 1 over t. And then that, you know, went right here within the product rule. Okay. All right. Well, let's see a few others. What about this one? So this one, I see a combination of 2 rules. So first, I see that this looks like y being u to the n power, because I know there is a logarithm. You know, I see it, and this rule is going to come into play at some point. But the big picture is that this function is u, like it's something to a power. So I'd have to use this rule first, okay? So here's the applicable rule for this one, that I see it initially to be u to a power n. And our rule for the derivative of that is that its derivative is n times u to the power n minus 1, then times du over dx. So it's n times u to the power n, take away, subtract 1, then times the derivative of the u. So, okay, so that's the rule that's initially applicable to this one. So we'll do like this. Say 1/2 natural log 9x, okay? Then, so I brought that power down. Now I've got to take 1 away. So 1/2 minus 1 is negative 1/2. All right, that's this part of it. Now when I go and find the derivative of the u, the function inside of that, that's natural log of 9x. Then I would have to use this, right? The derivative of natural log of 9x is 1 over 9x times 9. Okay, so let's do this. So first I've got that as like my big picture applicable rule. But then I would say, well, the derivative with respect to x of natural log of 9x, I remember what that rule said up there. It's a 1 over u, and u is 9x with respect to this, then times the derivative of the u. What's the derivative of 9x? It's 9. Okay, so 1 over 9x times 9, but I got 9 over 9, so it's 1 over x. So the derivative of natural log of 9x by itself is 1 over u times u prime, okay? That's what our rule set up there. Now, that all reduces to just 1 over x. So then I get this times 1 over x. All right, now, there's not a whole lot I can do to simplify this. The 2 and the x don't cancel or anything, and within the logarithm, anything in here is stuck in there and doesn't interact with anything on the outside. But I could do this much. I can at least kind of write everything in an orderly way. So I've got like a 2 and an x under the bar. And then I have square root natural log 9x down there too, because that power is negative, so I could send it under the bar and it would be positive, but it's a positive 1/2 power on natural log 9x would be a square root on natural log 9x. So I get it like that, clean it up, combine the few things that I can. All right, so obviously with the more complicated functions we get and the more rules that we learn, the more rules might be nested inside each other, because first I have to see that this rule is applicable. And then I get to this point where this other rule becomes applicable. All right, but they're applicable in stages, and I have to know, the order that things work out. So let's see. But I want to like map it out. So this part is here, and then this part is here. But I did work that out on the margin also. Okay, let's try one more. What's the derivative with respect to t of, this is a common logarithm, a logarithm base 10 of 6t. Now, logarithms have to have a base. I posted the review videos, but natural log of natural log of anything is a logarithm base number e. That's what natural logarithms are. So it's an ordinary logarithm with a base number of e. And then a log like this, like what we have, it just says log, and there's no base indicated. Well, there has to be a base. Like a logarithm is incomplete without a base. Like, so this one doesn't have a base. But, it's like there's got to be a base. You can't have a logarithm without the base. And so when the base is not written, then it's assumed that that base is 10. So this is like log base 10 of u. Okay, but nobody writes the 10. It's assumed it's a 10. Okay, so I might, for the purpose of the video, say that, well, okay, like what we really have here is log base 10 of 6t. And I do that because my rule requires that I know what the base is. So I got the derivative with respect to x of log base number a. A is some positive constant. Okay, well, in my example, it's 10. Okay, and the derivative of such a thing is 1 over u, natural log a times the derivative of the u. So let's rewrite it down here, because I like to have the rules next to each other. Derivative with respect to x of log base number a of u, okay, is 1 over u natural log of a. And then let's just write u prime, because I know we write the Leibniz notation, du over dx, but you could think of it as the derivative of the u, okay? All right, so let's see. Let's do like this. It's obviously I have applicability here between this example and this rule. T is the variable. I want to find the derivative with respect to t, the derivative of this with t being the variable, okay? This rule will be applicable, even though here I might be assuming x is the variable. This doesn't matter. So, okay, I get 1 over, so u in my case is 6t, and then I get natural log of the base, but the base here is 10, so natural log of 10, and then times the derivative of the u, that's the derivative of 6t, okay? But that's just 6. All right. So there it is. There's this rule. Okay, let's change colors again. All right, so you see our rule right there. Here it is, this step right there. Okay, final answer. Well, that may be my derivative. It always is that step. Like I use the rule, right? I use the rule the right way. That's the derivative. But do I have to write a 6 over 6? That's unnecessary. Those 6's cancel. And if that's gone, I can't cancel anything else. I'm going to be left with t natural log of 10. Okay, and then that will be my final answer, given that I canceled what I could, and that's what I'm left with. All right, so those are the derivatives of logarithmic functions. Now, in this video, it's just the derivative. All I'm trying to do is show you what the rules are and show you some examples of how I would use the rules, give you something to think about and something to go on from there. But I didn't explain what logarithms were and what the significance of the base is. That has been explained in previous videos I've posted. So if like you ended up here and you're like, what's a logarithm? I don't even know what I'm looking at. Then go back, look at the video list and look at the videos that are review or introduction to logarithms, that kind of stuff. And that'll get your bearings right on what logarithms are. And then hopefully the rules will look a little bit more straightforward if you do that.